Hey, welcome to week 5. This week we'll be learning about mapping change and measuring geographic distribution. Essentially, we'll be working with exercises from chapter 6 and chapter 7. So let's get started with chapter 6. I would recommend you all open up 6.1, which is under your GIST2 maps 6.1. Open that up, and then as part of this first tutorial, what we'll be doing is we'll be working for the chief of fire department who wants to do like a tabletop disaster drill in case a fire breaks out from this book matches factory or a manufacturer in Oleander. So you are asked to show the movement of plume over time or the time frame of the drill, which is which is for 4 hours, I believe. So what we'll be doing is we'll be working with the data that has been created by this Aloha Plume modeling software. We have four levels of data for each hour, and then we'll be using this data to actually understand how what is being affected and what land uses are being affected, and we'll create maps over time, which is over the next 4 hours, which is the for a 4-hour time period, which is the time frame of the drill. So what okay, so let's get started. The first thing is to open up the map, and then let's change the level 1 color to mango. Apparently, if you want, you can just type in mango or something. Probably not. All styles. Orange, light orange. Let's look for a mango color. I don't see a mango color. So see, color is not really that critical, I would say. Just like pick a color, like maybe from I'll just pick a color from here. There you go, that's mango. So just pick that color for level 1. And then we'll be looking at the first step here is to actually understand what buildings are being affected by this level 1 breakout or chemical plume. So what we'll be doing is select by location, and we will say the source layer would be level 1, and we are trying to select building footprints that intersect with the level 1 plume. So I'm going to click on apply. So as I can see, I have a building highlighted. So let's open up that building. Actually open up the building footprints layer, and it looks like it's a industrial building, and it's built in 1978, so it has 1 floor. So this information is pretty critical. So what we will do is create a map that would actually list out all the stuff in detail for the chief of fires, so that he has enough information for his records, sort of a thing, so he can actually put a plan in motion when something happens. So the first step is to add some text right here. So I'm gonna add some text, and I'm gonna say first hour 1 industrial building. So that's for the first hour. So I'm just going to move it down here, and then the next step is to look at the second R effect, which is going to select by location and then change this to level 2. Click OK. So we have multiple buildings here. So what do we do here? We can actually, before you do that, you have to change the level of transparency to a 50% for all these layers. So I'll be doing that throughout. So I'm gonna turn on my second level and change the color to okay, something slightly darker, fire red perhaps. Fire red. Click OK and then change the transparency to 50%. So I got the buildings that are affected by this second level plume, chemical plume. So I'm gonna go to my building footprints. I want a count of all the buildings by use code. So what I'll do here is I'm gonna right click and click on field, click on summarize, and here I'm gonna summarize this by use code. I'm gonna save it my GST2 folder, my exercises. I'm gonna save this as level 2. Actually you can just save it as a dbase file, level 2 dbf, and then actually you can save it under my data mdb and level 2 dbf. Save it and click OK. So what? Okay, that didn't work. Let's try again. Click on summarize. We can save this as level 2 buildings, level 2 DGS, and so let's add that map to the add that table to the map. Level 2 buildings, open the attribute table. Here as you can see, I got this by use code 1, 4, 5 and so on and so forth. But what do they mean? Let's take a look. Open the attribute table. Interesting. So although we got results that we wanted, we don't know what code 1, code 4 and code 5 are. If you actually go to page 199 in your book, these codes are explained. 1 means residential, 4 is industrial, and 5 is government. So we'll add these results to the text box. So essentially we'll create something like this. So essentially put all the information that you found in this box. You can worry about formatting a little later maybe. And then let's focus on the third R. Third R will change this to slightly more, even more red, I guess. So let's change level 3 to Mars red, and then give it a nice transparency of 50%. And now we're gonna go to select by location and we'll use the level 3 buildings. Okay, we got level 3 buildings that were affected by this. I'm gonna open the attribute table and do the same summarize table that we did before, and we're gonna call it level 3 buildings. Save it. Once we add it to the map, you can open the attribute table. So here we have 2, 3, 4, 5, 6 different types of land uses that were being affected. So you go back to your page 199 and look up those codes, the use codes, and create a summary like this. So in the third R you have about 1100 residential buildings, 44 multifamily, 32 commercial, 86 industrial, 46 government, and 3 school. So you put that information in the text box, and then you move on to level 4. So under level 4 you you do a similar analysis. Level 4, make it, I don't know, some kind of a darker red, give it a transparency of 50%, and then clear your selected and select by location and change this to level 4. Click OK. So once you are done with that, go back to your building footprint layer, and here you're gonna do the same step for, essentially repeat the same steps as before. Use code, call it level 4, save it, add it to the map, and then open it up and put this information back in the text box. So something like this for the 4 hours summary. And maybe if you want, you can break this into 2 columns, make a copy of this, copy this, paste it, and then put the 4th hour into a new column, maybe if you want that. And then this is about formatting. That's not the important lesson here, but if you want, you can do something like this, and then you can export the map along with the analysis that you found out for the fire chief to actually come up with a plan of action. And he would also like a time series analysis. So for this we'll use the time slider analysis, where there is a new tool available for doing this time tracking. So essentially what we need to do is turn off site 1, go back to your view by list by drawing order, turn off site 1, and here using catalog, go to SRI press GIST2 data, under drag site 1 time layer, site 1 time layer onto the map. So essentially what this is, it's a composite layer. Instead of actually having those in 4 different shape files, you have everything level 1, 2, 3 and 4 as part of one shapefile, which we can use. As you can see in the attribute table, you have R measure, shape length, shape area, and then we have this field right here, which actually shows us time, is the most critical one that we will use to actually map this. So right click on this layer, go to properties, and here we'll go to our time tab. So we're gonna click on enable time on this layer, and then we're gonna select for the time field. We know the R measure is the time field, and then here we're gonna select hours, minutes, days, hours, minutes, second, something like this, and then time step interval. We want this for every hour. If you have more detailed data, you can we can do as low, you can go as low as like a millisecond sort of a thing, but here an R is just fine. And then we're gonna click on calculate. Well, let's change this to an R again. And then we're gonna click on display data cumulatively, because the first R is not gonna disappear after the second R, so we're just gonna go with a cumulative effect. Click on apply. So, and then click on OK. So click on this time slider icon from your right here, time slider icon. Click on that. It will open up the time slider. Once you have it, what you can do is click on the play button and see what's gonna happen. So that looks pretty cool. So see, that's the kind of effect that you are looking for, sort of like how many buildings are being affected, and the extent of the plume over a 4-hour duration. So essentially, just save your map document and export this map as a JPEG or a PDF, and then work on your exercise 6.1. Good luck. Thanks. So welcome back to chapter 6, tutorial 6.2. Here we'll be continuing our mapping change exercises. As part of this exercise, we'll be actually mapping this tornado that actually had a touchdown in the northern part of the city. So we had some information from the local weather people, and now we need to map the tornado's magnitude and wind speeds while we try to estimate the damage, sort of a thing. So we have the data to do this. So just open up 6.2, and as part of the first step, open the properties of the tornado, the April 7 tornado layer, and then here you'll change the symbology from single symbol to quantities graduated symbols, and then you'll change the Fujita value to Fujita, and then the normalization is none, and then you'll change the color to a red color. Change the template to a red color. And here what we'll do is we'll increase the sizes from 6 to maybe, I don't know, maybe 10 to 20, something like that, and click apply. And then the next step is to actually symbolize the tornado path by graduated symbols, proportional graduated symbols again. And then the wind speed is what we'll be using for our values. And then the symbol sizes range from, we'll change this template to red color perhaps, or if you want to change it to something other than, like if you want to use your own symbol, that's fine too. And then we'll change the line weights from 1 to 8, maybe 7, something like that, just so we show this effect a little more intensely. So as you can see, we have mapped it quite well. We see the intensity of the wind speeds, we see the intensity of the tornado touchdowns and stuff, which is pretty good. And now that we need to create a buffer around this tornado's path, so that we can identify the areas of maximum damage. So the first step here is to actually click on the buffer tool search for buffer, and under tools you'll have buffer analysis, and then we'll actually buffer the tornado path of 07. The output feature class, you can save it under my data, call it tornado buffer maybe, and then the linear unit, we can use a field, the distance field. Instead of actually typing a constant value, we'll be using a graduated buffer, and then we'll use the dissolve type to be all, and then we'll use defaults for the rest of it, and click on OK. So once that's done, it should be added to the map. So we got our tornado buffer based on our buffer distances that were calculated based on the tornado path and the wind speed. The wind speed affects how much is affected, how wide an impact it had. So we'll use those. We have used those, and now we're going to change the buffer to a slight like a orange color, maybe something like that, and change the transparency to 50%. If you want, you can use a different color as well. So once that's done, we need to identify all the affected buildings based on this information that we got. So we're gonna select by location, and we'll select all the building footprints that were affected based on the tornado buffer that we just created. Click on OK. So once that's done, we should know we need to create a summary table that will actually identify different land uses that were affected and how many were affected and so on and so forth. So let's open up so we got 2000 buildings at 2045 buildings that were affected. So I'm going to click on use code and calculate. I'm going to summarize this table. I'm going to save this summary as tornado summary. So once that's done, let's add it to the map and open up the table that we just created. So, and we'll just go ahead and create a text box just like we did before, so that we can summarize this, something like this, where you have identified the damaged buildings, single family, the number of single families, so readjust the numbers, and now we have a informative map that has data associated with your analysis, a visual. So you can export this map, and then you can get started with your exercise 6.2. So good luck. So as part of tutorial 6.3, we continue mapping change using ArcGIS. So in this hypothetical example, we are trying to work with the city council who is concerned with the property values in the city. So essentially they have an assistance program, homeowners assistance program, which actually grants gives out like cheap loans and stuff to homeowners to remodel their houses, thus increasing their values. So they need to understand, they need to essentially identify target areas for this program to be implemented in, and they need us to provide a single family residential property that has increased in value or decreased in value more than 3% since 2010. So we have tax values in an, if you open the tax values, or this is an assuming a parcel database which has tax value of 04, 06 and 2000, and then you have DU, which is dwelling units, I believe, and then you have property descriptions and so on and so forth. So let's get to work. So the first step here is to open the properties of tax values and go to definition query. So if the dwelling unit is not equal to 1, which means it's not a land use that we are worried about, so we're just gonna click on DU and is equal to 1. If it is more than 1, which means it's multifamily, it's less than 1 or 0, which means it's a non-residential use. So essentially we're gonna go with the DU is equal to 1, which is a single family residential. Click on apply, click on apply. So as you can see, our selection is, our definition query has narrowed the city down into essentially half of it. So now that that's done, open the attribute table. We're going to create a new field. We're going to add a new field call it percent change 12 and set the field type to float and click OK. And now we will actually calculate the percentage change. But there is a potential problem. So we need to be, let's arrange these values by ascending order or something. You see the tax value for some of these properties are 0, so we can't really have zeros as a denominator, so we have to redefine this, or only calculate the percentage change for those the value has. So essentially we need to sort of like not calculate, not apply the formula on these values, tax values in tax value 12, 1, 10. So what do we do here? We go back to our definition query and we say go back to definition query. Here we'll say that we'll add a couple more layers to this definition query. We'll use the AND operator and we use parenthesis, and within that we will say tax values 12 is not equal to 0 and tax value 10 is not equal to 0. So which means it will essentially give us the properties that have that does not have a denominator of 0. So that's good. Now we'll calculate our percentage change. We'll go to field calculator and we use the formula tax value 12 minus tax value of 10 divided by tax value of 10. Put that in brackets and divide that by tax value of 10 and multiply the whole thing by 100. So once you do that, you should get your percentage change in value from 2010 to 2012. So we'll use that to actually create a thematic map. To create thematic map or symbolize this layer based on quantities. and the value is going to be percentage change. That is, so either we can go to classify, and in the sampling size we can increase this value, because we had when it said, when we clicked on percentage, it says it has reached a maximum sample size. We can increase that, or we can just keep it like this. Essentially what we are looking for is anything that's less than 3%, right? So what we need to do is make sure this map communicates that. So we'll essentially classify the data and say this is the decrease is -3. So that's our first break value, -3 and 0. -0, 0, 3 and 16. So use that and format the labels so that the decimal places are not awkwardly big, maybe 1 or 2, maybe use that, and then I would relabel them, because this is greater than 3% decrease, 0 to 3% decrease, no change essentially, and then you have 0 to 3% increase, 0% to 3% increase. So this way the map is easily readable, and more than, so this way nobody is confused with the map and it's fairly clear what's going on. Also, I'm gonna turn off the lot boundaries layer just for once, just to see what's going on. It looks like this area here has a lot of red in it, so I'm gonna zoom into that layer. As you can see, that neighborhood in particular is severely affected. Looks like something's wrong there. Maybe you can start your program there or something. So anyways, this could be one of your target areas. So this is a map they're looking for. Save your map and then get to tutorial exercise 6.3 for your assignment. Good luck. Hey, welcome to chapter 7 of book 2, measuring geographic distribution. In this chapter we'll be working with the data from Fort Worth Fire Department in Texas, where the fire chief apparently is pretty impressed with your hypothetical work, and so he has hired you to actually do some more analysis, and we will be working with a bunch of data, calls for service from Feb 07 and proposed stations and active stations, and using this data you'll be finishing tutorials 7.1 to 7.3. So the first step is chapter is to identify mean centers. So open your 7.1 documents, and here you'll be, so what you are looking at is battalion 2. This red boundary is battalion 2, and we are looking at the 911 call for service calls, request for service calls, and then you have the existing and proposed fire stations. So in this 7.1 you'll be actually you'll find the mean center for all these calls and find a central feature for battalion 2. So that's what we're gonna do. So you'll run the map center tool. What you need to do is click on search and click on tools and find map center. If you don't find it, actually it's mean center, I'm sorry, mean center, spatial statistics. Click on mean center, and then the input feature class is going to be your service calls for service. The output features call, you need to save that as battalion 2 mean centers. And the weight and the case failed is going to be the station ID, is the station, and the dimension field is going to be none. Click on OK. So what you'll see here, so what you have done is you created this shape file which has calculated for the 5 station areas 1, 2, 5, 8 and 14 the mean center. As you can see, let's flash this, that's the mean center. If you want, change the symbology to maybe like a yellow or something like that, so that you can see the mean centers a little more. If you want, change the color to green perhaps. So as you can see, the location of fire stations versus the location of the mean centers, so most of these are pretty close to each other, and some of them are a little off. So again, this actually gives you a fair idea of where the ideal location for a fire station, because a mean center is equally accessible to all the calls in theory. So anyways, this is 1 month of data. Maybe if we had more data, we can calculate the mean center a little more accurately. But then again, this is the kind of stuff that would be useful in your decision making process. So also you can notice that the station 8 is closer to the mean center than the existing station. The proposed new location is pretty close, so maybe it's not a bad location to actually move your station to. But for district 5 it looks a little off, to be honest with you. So so the next step is the station chief wants to relocate the head office, and he wants to actually sort of like run an analysis on the central feature so that he can go ahead and approve the budget for that. So we need to identify the central feature, so click on search. So before we do that, from the main menu, click on select by attributes, where build the following query. We need to identify only the stations that belong to battalion 5. So click on active stations, and here the battalion is equal to only 2. So since let me run that real quick again. Attributes, active stations. Okay, we got the stations that are from battalion 2. So now we are going to open the central feature tool. Central feature, and using this we'll be finding out what is the most most centrally located feature. So input the center feature for active stations. Here the output feature class would be battalion 2 central feature, bat2 central feature, and then we'll use the Manhattan distance. So Manhattan distance, you can read the differences between those two. Euclidean is mostly Crowline, but the distance between the 2 points is measured along the by summing up the absolute difference between x and y coordinates, sort of a thing. It's a it's sort of like using the city blocks into the equation. So Manhattan is a much better distance method when compared to Euclidean, if you have the data for it. So on the weight field is none. We'll just go ahead and run this analysis. So we'll find what is the most central feature between these stations, and we found the central feature to be station 2. So which is excellent, because so station 2 is the central feature, so you want to, so this is the most central feature, which means he'll be in the most accessible location to the rest of the stations in the battalion, but it doesn't mean he's centrally located for all the service calls. He won't be any closer to all the service calls, because that's not the analysis we have just run. This is about finding out what is the most centrally located feature for your, this could be finding out where to have your headquarters, sort of a thing. So anyways, that's 7 as part of 7.2. Let's, so again, just to be sure, so this could be your customer data. Instead of 911 calls, this you could be trying to locate a new trying to find a new location, or maybe trying to move an existing location to a more appropriate location based on your customer base, and so on and so forth. So these are real world examples that have, this method can be used across different scenarios. So let's open up map document 7.2 from your maps folder, and in this scenario, once again we are working with the Fort Worth Fire Department, and this time what they have done is they have provided some weights to each one of these 911 calls. So essentially what they are saying is, okay, what the analysis you have done is good, but not all calls are equal. Some of these calls are just like false alarms, sort of a thing, and some of them actually do carry some weight. So you need to prioritize based on the FEE value, which is actually from fire and EMS evaluation, and they have given a rating of 1 to 10, 10 being the highest importance and 1 being the lowest, a value to each one of these calls. So we need to actually take that into account while calculating our means centers. So let's rerun this analysis. I'm going to click on search and look for means center. I'm gonna click on means center spatial statistics. So what we need to do is, the input features are going to be calls for service. The output feature class again will be battalion means centers, but this is weighted, and the weight field is actually the FEE. So let's use that and click. Oh, and the case field is actually the station, so that we know which station these calls are going to, so that they know what sub area to look for when calculating, while calculating these means centers. And click on OK. So our mean centers have been calculated. Let me change the symbology to maybe, okay, dark blue, something like that. Now I can see the mean centers have shifted slightly from last time. So if you want to actually compare those two. Let me add the other GIS2 data, my exercises, my data. Let me add those mean centers that we have calculated before and show you the difference between those two. So the yellow ones are the ones we calculated before, the blue ones are the ones that we have now. They're slightly different, they're not that much different, but they're slightly different. But nevertheless, they give us a much better idea, or we can say with some certainty to the fire chief that okay, we have taken into account all the factors while calculating these mean centers. So the next step is to actually try and calculate the central feature but this time we'll be using a weightage of total employees at each one of these stations, so that we get a prioritized or a weighted mean center again. So central feature, let's find central feature. So here what I'm going to do is the input feature is going to be active stations. Oh, before I do that, I need to select the stations from battalion 2s. Select by attributes, active stations, battalion is equal to 2, and now I'm going to start my central feature tool and select active stations. Put feature class is mean centers weighted. No, actually central feature weighted, I'm sorry. And then the weight field is total number of employees. So before we did not account for the total number of employees located at each one of these centers or stations. Now we say okay, let's look at that. If we don't want to really move the headquarters from to a station just because it's centrally located, we need to account for the total number of employees that are at each one of these stations. So let's account for that. Click on OK. So based on that, we have a new centrally located station, looks like, which is now at station in the district 5 or station 5. Before it was in the station 2 area, now it's at station 5. So as you can see, because of the weighted because we have weighted this based on the total number of employees, this is a much more centrally located features. So this is how you use weights or assign weightage to your analysis. This way you have a much better analysis and you can be confident about your findings. So welcome back to 7.3. In this tutorial we'll be learning about calculating standard distance. So standard distance, it measures the degree to which the features are concentrated or dispersed around the points in an input feature class. So the input feature class is always a point layer, and it sort of calculates where is the mean center and how sort of like draws these circles around these points, which actually says where is the mean center and how these points are actually distributed from that mean center. So it actually uses standard deviation in calculating these. The first standard deviation calculates covers or the area or the circle that is being generated. The first standard deviation circle actually covers 68%. The two standard deviations usually cover 95% of the features. So we'll see how this is done and what this means. So in this scenario, again, we are using the battalion 2 data for the Fort Worth Fire Department, and we'll be essentially performing this standard distance analysis on the same data. So let's open 7.3, and here will be the first step is to search and find standard distance to standard distance of spatial statistics. See, that's what I was talking about, the input features. If you input a bunch of features, point features, a standard distance is calculated or a circle is outputted based on the dispersion. So the first the input features in this case are calls for service, and then we'll call this battalion 2 standard distance. Save this. Circle size, one standard distance actually calculates 68%, 2 means 95, and 3 means 100. So I'm gonna go with the first standard deviation. Weight field is actually none for now, and the case field is station, and click OK. So as you can see, this is first standard deviation, which means it is covering about 68% of the data. So let's change the symbology of this. I'm just gonna go with the symbology that I have in my, and then change the transparency to 50%. As you can see, that's the symbology that I used, and that's the that's how the features are distributed and around their mean centers. So what we need to understand here is that station 1 and station 14 have really large circles, which means their travel time from the station to responding to all these calls is pretty high. And also the relative importance of the 911 calls, the FEE that we used before for the weightage, is not taken into account, and actually you are more concerned with the travel time that do all the important calls than anything else. So let's run the same analysis using weightage. So I'm going to go back and rerun the standard distance, but here the weight field, I'm going to use the FEE as a weight field, and then save this as standard distance weighted, and then click OK. So now I get a slightly different as you can see, my circles are slightly shifted. They're sometimes smaller, looks like. So again, this is a weighted analysis, so this is, you can use this a little more confidently. So good luck with your 7.3 exercise, which is the assignment for this chapter. Okay.